All right, so diving into some really cool research today. The paper is called GarmentCrafter, Progressive Novel View Synthesis for Single View 3D Garment Reconstruction and Editing. Catchy title, right?
Definitely rolls off the tongue.
But titles aside, this is pretty groundbreaking stuff. We're talking about making 3D models of clothes just from a single photo. And not in some clunky professional software kind of way, but something way more user-friendly.
Yeah, you hit the nail on the head. This is all about giving everyday people the power to create and play around with realistic 3D clothes, without needing a design degree or anything.
Exactly. Like, imagine seeing a cool jacket online and wanting to see it from all sides. Or maybe you have a picture of a vintage dress you love and want to make a 3D version for a virtual world. That's what this paper's all about.
Totally. And the real kicker is that it does it well. Current methods for this kind of thing, they either need a lot of skill or the results just don't look quite right.
So what's the magic behind GarmentCrafter? What's the big breakthrough that makes it so different?
The real game changer is this idea of depth-guided progressive synthesis. So instead of just trying to guess what the 3D garment looks like from a single photo, GarmentCrafter uses the depth information in that photo to guide the AI as it creates those new views.
Depth information, you mean like how far away different parts of the garment are from the camera?
Precisely. It's like the system first tries to understand the basic 3D shape from the 2D image, kind of like figuring out how far things stick out. Then it takes it a step further. It starts generating those new views, like from slightly different angles, using what it learned about the depth to fill in the missing pieces.
I see. So it's not just randomly creating new angles, it's using that 3D depth info to make more informed guesses.
Exactly. It's a step-by-step process, kind of like peeling back layers of an onion, but in 3D. This progressive approach, combined with that initial understanding of depth, is what sets it apart and makes those 3D models way more realistic and consistent than before.
Makes sense. So let's break down the paper a bit. The abstract, which is like the paper's elevator pitch, starts by talking about this progressive depth prediction and image warping for novel view synthesis. Then it mentions a multi-view diffusion model. What's that about?
Right. So that model comes in after the initial depth-guided part. It's used to complete those hidden regions of the garment that you can't see in the original photo. And what's really neat is that this model is specifically designed to make sure all the different views mesh together perfectly, like they're all part of the same cohesive 3D object. The authors even highlight how visually impressive the results are and how well the different views fit together compared to previous methods.
Sounds promising. So backing up a bit, what exactly were the researchers trying to solve with this paper? What were the limitations of older techniques that led them to create GarmentCrafter?
Okay, so the introduction section lays out the motivation pretty clearly. There's this huge demand for easier 3D garment creation tools, especially for folks who aren't professional designers. Current software for this is powerful, sure, but it's super complicated to use. And previous attempts at recreating 3D clothes from a single image, they often fell into two categories, neither of which was ideal.
Okay, I'm listening. What were those categories?
Well, some methods relied on trying to fit the 2D image onto a pre-existing 3D template of a body or a generic garment. The problem there is that clothes come in so many different shapes and styles that these templates often miss the mark. They just can't capture the nuances of real clothing.
Right, that makes sense. One size doesn't fit all when it comes to clothes. What was the other category?
The other approach was to use AI to, basically imagine what the garment would look like from different angles. But without a good grasp of the 3D structure, these AI-generated views wouldn't line up properly. Like, you'd end up with a 3D model that looked off, kind of disjointed.
So GarmentCrafter aims to solve both those problems.
Exactly. And the researchers specifically point out that garments have incredibly diverse shapes. And capturing those little details, like wrinkles and complex patterns, in a way that looks right from every angle is crucial. Their core idea, that progressive novel view synthesis, using depth as a guide for the AI, is meant to tackle these limitations head-on. It not only aims for better-looking 3D clothes, but also opens up really exciting possibilities for editing those clothes in a more intuitive way. And importantly, they train their system on a massive data set of 3D garment models, giving it a solid understanding of how clothes actually work in 3D.
So how does GarmentCrafter compare to other research being done in this area? What sets it apart from the crowd?
The related work section does a great job of placing GarmentCrafter within the bigger picture. They clearly distinguish themselves from those template-based methods we discussed. Their approach doesn't rely on predefined shapes, which gives them much more flexibility to work with all sorts of different clothing styles.
Flexibility is key. What about those AI methods that just generate new views without that 3D depth information? How does GarmentCrafter improve on those?
That's another key point they highlight. Those 2D methods might create images that look good on their own, but they struggle with what's called cross-view consistency. That means if you look at the generated garment from multiple angles, it might not feel like a believable solid object. GarmentCrafter's use of depth-based warping provides a much stronger foundation for ensuring that all the different views actually look like they belong to the same 3D garment.
Ah, so those warped images are key to getting that consistency. Makes sense. They also mention research on generating new views from just a few images, right?
Yeah, and their approach differs there too. GarmentCrafter actually uses the initially warped image as a starting point, which turns out to be much better for getting consistent views compared to methods that try to generate each view independently.
Interesting. So it's all about leveraging that initial depth information as effectively as possible.
Precisely. And they also point out that while there's research on generating entire 3D scenes from images, garments need a special level of precision, especially for editing and making sure the 3D shape closes up properly. That goes beyond what's needed for general scene reconstruction. They really nail down their unique approach of progressively using warped images to create a detailed 3D garment, and even the creation of their detailed 3D garment dataset was a significant achievement.
Okay, enough with the comparisons. Let's get into the nitty-gritty. How does this progressive novel view synthesis actually work? Walk us through it step by step.
All right, so the approach breakdown section dives into the technical details. Their primary goal is to take that single garment image and create consistent views from different angles. That means generating both the color information and the depth information. Also, they can create a solid 3D model that can be edited later on.
So far, so good. What's the first step?
The very first thing they do, as we touched upon earlier, is estimate a depth map from the initial image. They're essentially trying to figure out how the garment is laid out in 3D space. This allows them to create what's called a colored point cloud, which is essentially a sparse 3D representation of the garment.
So it's like a rough 3D sketch based on how far away different points in the image seem to be.
Exactly. And this is where the clever part comes in. They simulate a virtual camera moving around the garment in a closed loop, like it's orbiting the garment. At each position along this loop, they project the existing 3D point cloud onto that new camera's viewpoint.
I'm picturing it now. So what happens at each of those viewpoints?
Well, because the point cloud is just a sparse representation, this projection creates an incomplete 2D image. Some parts of the garment will be hidden from that new angle. They also get an incomplete depth map corresponding to that view. To fill in these gaps, they use a special kind of AI model called a conditional image generation model. You can think of it as an AI that's been trained on tons and tons of clothing images and has learned how different parts of garments should look and connect.
So this AI can sort of intelligently guess what the missing parts should look like.
Exactly. It takes the original image, the incomplete projection from the new viewpoint, and the virtual camera's position as input. Then it uses all that information to in-paint the missing areas, making sure they look right based on what's already visible and based on what it knows about clothes in general.
Wow, that's pretty cool. What about the depth information? Do they just guess that too?
Nope. They have a separate process for refining the depth information for these new views. They use a different AI model that's specifically trained to estimate depth, and they condition it on the completed RGB image and the warped depth from the previous view. This ensures that the 3D understanding stays accurate throughout the process.
So it's like a double check, making sure the colors and the 3D shape are both making sense.
Exactly. And once they have this new color and depth information, they incorporate it back into the 3D point cloud. Then the whole process repeats as the virtual camera moves to its next position along that loop.
So it's like this constant refinement process. Each new viewpoint helps to complete and improve the overall 3D model.
Precisely. And the paper doesn't stop there. It also goes into detail about how they use this 3D information for digitization and editing.
Okay, I'm all ears. How do they go from that point cloud to an actual 3D model that you can interact with?
Once they have those consistent multi-view images and the refined pine cloud, they use a technique called screen Poisson surface reconstruction. This creates a solid 3D mesh of the garment and also allows them to wrap the original texture from the photo onto the 3D model, making it look realistic.
So now we have a fully textured 3D model. What about the editing part?
Right. That's where things get really interesting. They describe two main ways you can edit the model. The first is called part-based editing. This lets you select a specific part of the garment, like a sleeve or a collar, and make changes to it, maybe make it wider or change its shape.
So I can just click on the collar in the 2D image and tweak it.
Yep, pretty much.
Mm-hmm.
And the system then removes that part from the 3D model and uses that progressive synthesis technique we talked about earlier to reconstruct it with the new style, ensuring that it fits seamlessly with the rest of the garment from all angles.
That's clever. And what's the other editing method?
The other method is local surface editing, which allows for more fine-grained adjustments to the shape or texture of a specific area. It gives you more control over the details.
It all sounds very user-friendly, but how did they actually train this system to be so good at reconstructing and editing garments?
They dedicated a whole section to their data preparation and training strategy. Basically, they created a huge data set for training by simulating this whole process with many different 3D garments. They generated pairs of single-view images and corresponding multi-view data, which they used to train their AI models for both image and depth generation. They even simulated edits on these 3D garments to specifically train the editing capabilities of the system.
That's smart. So they basically taught the AI what good reconstructions and edits should look like by showing it tons of examples.
Exactly. And to make the system even more robust, they included random rotations during training, so it can handle images of garments in different orientations, not just perfectly straight-on shots.
Very thorough. So with all that effort put into training, how well did it actually perform? Does it live up to the hype?
The experimental validation highlights section dives into the results. They tested GarmentCrafter on multiple public data sets of 3D garment models, representing a variety of styles and complexities. To evaluate the visual quality of the generated images, they used standard metrics like LPIPS, PSNR, and SSIM, which basically measure how similar the generated images are to real images. And for the accuracy of the 3D shape, they used something called chamfer distance.
So they had ways to measure both how good the images looked and how accurately they captured the 3D form. What did they find?
The results were really impressive. They compared GarmentCrafter to several other state-of-the-art methods for this kind of single-view reconstruction. In every comparison, both for image quality and geometric accuracy, GarmentCrafter came out on top. It consistently produced sharper textures, captured finer geometric details, and handled complex patterns more effectively than the other methods.
Sounds like a clear win for GarmentCrafter. What about the editing capabilities? Did those work as well as they hoped?
Absolutely. They included visual examples of both part-based and local surface edits, showing how changes made in the 2D image were accurately reflected in the 3D model from every angle. It was clear that the edits were consistent and seamless, just like they intended.
Very cool. Anything else stand out in the results?
One interesting thing they did was an ablation study. This is where they remove or change parts of the system to see how much each part contributes to the overall performance. In this case, they tested the impact of their progressive novel view synthesis, or PNVS, approach. And what they found was that it was absolutely essential for achieving those high-quality images and consistent views. They even created a new metric called the Cross-View Consistency Score, or CVCS, to specifically measure how well the different views aligned. And their method showed a big improvement in this metric compared to the others.
So they proved that their unique approach was really making a difference.
Exactly. And one final point they explored was the impact of that zigzag pattern they used for the virtual cameras movement. They found that this back and forth motion actually led to better overall reconstruction quality compared to a simpler circular path.
That makes sense. It's like getting a more complete view of the garment from all those slightly different angles.
Precisely. The researchers argued that this motion helps resolve any ambiguities and capture the garment shape more fully. And finally, the conclusion and limitations section summarizes their contributions and honestly acknowledges that there's still room for growth.
So what are some of those limitations? What are they looking to tackle next?
Right now, GarmentCrafter focuses on garments in static poses, like, not moving. And they only reconstruct the outer surfaces, not the internal layers. But they hint at future work that will address these limitations, so it'll be exciting to see what they come up with next.
This is definitely a huge step forward in the world of 3D garment modeling. To fully appreciate how far we've come, can you give us a little historical perspective on this field?
Sure. The way we create 3D garments has come a long way. In the early days, it was all very manual. Skilled artists would spend hours creating virtual clothes piece by piece using specialized software. Then came template-based approaches, where designers would try to fit pre-made 3D shapes onto 2D images or body scans.
Right, but we talked about the limitations of those templates. They weren't very flexible.
Exactly. Those methods really struggled with garments that had unique styles or complex draping. Then computer vision and machine learning started changing the game, with algorithms learning to connect 2D images to their 3D counterparts by analyzing massive datasets. But even with these advances, it was still incredibly challenging to get those really high-quality reconstructions with fine details, especially from just one image, while keeping the whole process easy for non-experts to use. There's always been this trade-off between accuracy, detail, and ease of use.
And that's where GarmentCrafter shines.
Precisely. It builds upon the latest advancements in AI, but grounds them in solid geometric reasoning through depth estimation and that progressive view synthesis. This combination really pushes us closer to that sweet spot where we can have both stunning realism and intuitive user control. And it's part of a larger trend in computer graphics and vision to bridge the gap between the 2D world and the 3D world, making it easier to create and interact with 3D content.
All right, so to wrap things up, what are the key takeaways our listeners should remember about GarmentCrafter? What makes it so noteworthy?
The core innovation is their progressive novel view synthesis approach, which is driven by that initial depth estimation and warping. That's what allows them to create consistent 3D models from a single 2D image in a way that just wasn't possible before. By generating and refining views from all those different angles, they achieve a level of accuracy and coherence that's really impressive.
And what about the practical implications? Who benefits from this technology?
The applications are vast. Think about online shopping. This could lead to much more realistic virtual try-on experiences. Instead of just seeing flat images, you could actually see how a garment would look and fit on you in 3D, based on a single photo from the retailer. That would change online shopping in a big way.
No more guessing about fit and style. I love it. What else?
It also has huge implications for creating digital fashion assets for online stores and virtual worlds. Designers and content creators could easily generate and customize 3D clothes for avatars and virtual characters. It could even help people create more realistic and personalized digital avatars for themselves. And the best part is that it makes these tools more accessible to a wider range of people. You don't need to be a 3D modeling expert to benefit from this technology.
That democratizing aspect is really exciting. Now it's time for our Novel Notions segment, where we speculate about future research directions based on the paper we've discussed. What are some exciting possibilities that GarmentCrafter opens up?
One really cool idea is to explore how we could extend this progressive view synthesis to handle dynamic garments, clothes in motion. Right now, GarmentCrafter works with static poses, but imagine being able to take a single image of someone dancing or a dress flowing in the wind and generating a full 3D animation of that garment.
That would be incredible. How could we make that happen?
It would likely involve combining techniques from video understanding and maybe even physics-based simulations to predict how the garment moves and deforms over time. There's already some interesting research on capturing and modeling moving objects from video, so building upon that would be a good starting point. The challenge would be to maintain consistency not only across different viewpoints, like GarmentCrafter already does, but also across time. Every frame of the animation would have to flow smoothly into the next and look believable.
That would be a huge leap forward. What's another research avenue you'd like to see explored?
Another fascinating direction would be to connect GarmentCrafter with other AI models that are really good at generating images and 3D shapes. Imagine being able to reconstruct a 3D garment from a single image and then just tell the system what you want to change using natural language. You could say things like, add a ruffled collar, or make the sleeves longer and wider, and the system would modify the garment in 3D, automatically ensuring that those changes look right from every angle.
So it's like combining the power of text-based commands with 3D editing.
Exactly. There's been amazing progress in AI models that can generate 3D objects from text prompts and even edit images based on natural language instructions. Integrating those capabilities with GarmentCrafter could lead to a whole new level of creative control. Of course, there would be challenges too, like making sure the AI understands what you mean and creates edits that are both stylish and physically plausible.
These novel notions are definitely food for thought. It really feels like we're just beginning to explore the potential of AI for creative tasks like this.
I agree. And it's important to remember that these are just ideas, not guarantees. But they highlight the potential of groundbreaking research like GarmentCrafter to spark new innovations and change the way we think about design and 3D content creation.
Well said. Well, that wraps up our deep dive into GarmentCrafter. This research truly pushes the boundaries of what's possible, making 3D garment creation and editing more accessible and intuitive than ever before. If you're itching to learn more, we'll include a link to the original paper in the show notes. And before we sign off, one last question for our listeners to ponder. How do you think these AI-powered tools will shape the future of creativity and our interactions with digital content in the years to come? Thanks for joining us on the Deep Dive.